Assalamu alaikum. Today we will continue discuss some review example and problem in thermodynamic. So if we have example an M1 equal 485 جرام brace block sides in boiling water T1 بتساوي 100 Celsius. It is taken out of the boiling water and placed in a cup containing M2 equal 485 gram of ice water T2 equals 0 Celsius. What is the final temperature T final of the system? Or in other words, when the two objects have the same T and C براس equal 380 جول لكل كيلو جرام كلفن and C للووتر بتساوي 4184 جول لكل كيلو جرام كلفن. We have some multiple choice. A, the final less than 50 Celsius or equal 50 Celsius or greater than 50 Celsius. After we solve this, we have to choose one of the following. So in solution, we have T1, M1, and T2, M2. We have a brass and water. Okay, so heat flows from brass to the water. This means no work is done, and we assume that no energy is lost to the environment. And we have to remember that Q equal C multiplies by delta T, and C equal MC delta T. Q1, so brass heat flow out Q1 equal delta U1 وتساوي M1 C1 في T final minus T1, and water heat flows in Q2 equal delta U2 وتساوي M2 في C2 في T final minus T2. And we know that is the energy is conserved. This means that Q1 plus Q2 which equals 0. And we have to solve for T final. Then we substitute this equation Q1, Q2 and the energy is conserved. So T final equal M1 في C1 في T1 زائد M2 في C2 في T2 divided by M1 C1 زائد M2 C2. إذا if we arrange again, so C1 T1 زائد C2 في T2 over C1 زائد C2, and this is equal 8.3 Celsius. So the T final will be is less than 50 Celsius. Okay, in kinetic theory, the speed of molecule in air. Air is a primary a mixture of nitrogen and two molecules. Molecular mass, the nitrogen 28 U and oxygen O2 molecules mass equal 32 U. Assume that each behaves as an ideal gas and determine the RMS speed of nitrogen and oxygen molecule when the temperature of the air is 293 Kelvin. So we know the solution for the kinetic energy نص M V RMS square equal 3 over 2 kT, and VRMS equal the square root 3 kT over M. So now we have to substitute for nitrogen M. What's M? M is 28 جرام بير مول. إذا بدنا نحولها للماس 28 جرام بير مول نقسم على عدد افوكادرو نمبر 6 في 10 القوة 23 مول انفرس. النتيجة equal 4.65 في 10 قوة ناقص 26 كيلو جرام. Then VRMS equal 3 KT over M. So 3 في K is Boltzmann constant and temperature is 293 Kelvin divided by the mass. So VRMS equal 511 meter per second. And we do the same for oxygen. Example 3. In this example, a container of an ideal gas has a movable top piston. إذا في عندنا piston movable متحرك. The top has an area of 0.01 meter square and is 50 centimeter. So we have the top, this is the area of the piston, okay? And a mass of 200 kilogram is placed on the container. إذا في عندنا mass 200 kilogram وضعناه بالcontainer which compress the gas by جبنا mass وضعناها فوق up of the piston انضغط الغاز so which compress the gas by 20 centimeter. إذا انضغط الغاز من هون لهون 20 centimeter. Okay, this is one. If we take line from here, okay, the gas in the container is initially at atmospheric pressure 1 في 10 القوة 5 باسكال and 20 سلسيوس. إذا كان عندنا على 1 atmosphere في البداية 1 atmospheric pressure 1 في 10 القوة 5 باسكال عند درجة حرارة 20 سلسيوس. What is the new temperature of the gas? In solution, we will start from the ideal gas law. BV بتساوي nRT and BV over T بتساوي constant. So B1 في V1 over T1 تساوي B2 في V2 over 2 T2. And we solve the for T1 and we have the volume. The volume equal الاريا في الارتفاع and the area 1 of course equal the area 2 because the area is the area of the piston and the volume 1 equal A area في H1 and volume 2 equal area في H2 because we have a difference of 20 centimeter. So and T1 تساوي T1 S زائد 273 اللي هي 20 كان عندنا وتساوي 293 كلفن. إذا B1 تساوي B نوت at initial وتساوي 101 كيلو باسكال. B2 راح تساوي B نوت زائد الفورس على الاريا. اوكي we have the initial pressure أو atmospheric pressure اللي هي B نوت زائد بما إنه إحنا حاطين ضربنا بالفورس إذا راح يكون الفورس على الاريا والفورس بتساوي هي عبارة عن الماس في الجرافيتي. إذا B2 تساوي B نوت زائد الفورس mg over area وتساوي 297.2 كيلو باسكال. Now we substitute all values. So T2 تساوي B2 في V2 على T1 على B1 في V1. النتيجة area with area it's cancel each other because the area of the piston is the same and which equal 517.6 Kelvin and in Celsius which equal 244 Celsius. Okay. Okay, we go to thermodynamics flow. Some example. The process shown in the pressure volume. We have a pressure volume, and this is the process. diagram. What's this? Is adiabatic expansion or isothermal expansion or isometric expansion or isobaric expansion. We see here at a pressure it's constant, then it's isobaric expansion. Another example in isochoric process or isovolumic process, there is no change in pressure, temperature, volume, internal energy. In isochoric process, the volume is constant. In this case, it's the volume. Okay, another example. The process shown in the temperature volume graph is an what's this between T and V? Adiabatic compression or isothermal compression or isochoric compression or isobaric compression. Okay, we will. It's not isochoric. It's not isobaric compression. Then we have to choose between adiabatic compression or and isothermal compression. What's this? In this case, we have isothermal compression. When the first law of thermodynamic Q equal delta U plus the work is applied to an ideal gas that is taken through an isothermal process. So delta U equals 0 or the work equals 0 or Q equals 0 or none of the above. So in this case delta U بتساوي 0 cause isothermal process. Another example, an ideal gas is compressed to one half its origin volume during isothermal process. This time the pressure of the gas increased to twice its original value, increased to less than twice its original value, or increased to more than twice its original value, or does not change. Then we have to solve this problem, and after solve this problem, we choose the answer by increase to twice its original value. Okay, another example, when the first law of thermodynamic Q delta U equal the plus the work is applied to an ideal gas that taken through an adiabatic process. إذا عندنا العملية هون adiabatic process. So what is the answer? It, when said adiabatic process, this means no heat flow. Then Q equal 0. Another example, a gas is taken through a cycle illustrated here during one cycle. And then we have this cycle, we move from here, and they ask how much work is done by engine operating on this cycle. BVV, 2 BV, 3 BV, or 4 BV. Look here, between B to B, even the difference here is 1B. And here is the volume V, and here is 4V. Here is constant pressure. He asked about the work. The work equal B, the pressure times the change of the volume, delta V. Then in this process at V, this one is the work is 0 because the volume is constant. And also here, the volume is constant. So the work is 0. So what we have? We have this one plus this one. So from here, we have 1B delta V, B, V final minus V initial. Then we have 4V minus V, which equal 3BV. Okay. Another example, an ideal gas initially an ideal gas initially has a pressure P naught. At volume, at volume, V naught and absolute temperature T naught, it then undergoes of the following series process. Heated at constant volume to pressure 2 P naught. Heated at constant pressure 3 V naught. Then we have process 1, 2, 3, 4. And then we cooled at constant volume to pressure P naught, cold P naught, and cooled at constant pressure to volume V naught. Okay. Find the temperature at each end of the point in terms of T naught. إذا بدنا نشوف temperature at end of this points. Here we have this PB بتساوي nRT and T naught in this case تساوي B naught في V naught nR, and then here if we substitute the values here at 2 T naught, and this is 6 T naught, and this point is a 3 T naught, and at initial is T naught. Again, find the net work done by the gas in terms of P naught and V naught. Net work equals net area under the curve, and in this case the work equal to P naught V naught. How? The area is the width times the height. So what we have the width 2 V naught from here to here مضروبة في ايه؟ في الديفرنس اللي هي هذه ارتفاعها P naught. Then we have minus 2 P naught V naught. Why is minus? Negative because since it's a clockwise cycle. إذا ماشيين مع عقارب الساعة. From 1 to 2, 3, 4. Okay. Find the net change in internal energy in terms of P naught and V naught. Net energy delta U in this case equals 0. Why? Because uh, we have delta U equals 0 for any cycle, since delta U equals 0 and Q تساوي minus the work. We have this work and minus work, the total is equal 0. Then delta U equal 0. Okay. Determine the heat transfer during process 2. Then we have process 2 in terms of P naught and V naught. For the process 2, the work equal minus B في delta V, and this is equal minus 2B naught مضروبة في 3 V naught ناقص V naught. النتيجة تساوي ناقص 4 B naught V naught. And we know that delta U بتساوي 3 على 2 NR delta T وتساوي 3 على 2 NR في دلتا T تساوي 6 هون T نوت ناقص 2 T نوت وتساوي بلس 6 NR T نوت وتساوي in this case 6 B نوت V نوت. إذا Q تساوي دلتا U minus the work وتساوي 6 B نوت V نوت ناقص the work ناقص 4 B نوت V نوت. النتيجة تساوي 10 B نوت V نوت. Okay. Then this is the end of some example in this lecture, and we continue next lecture for other example. So thank you for your attention.